Hey, thanks for joining me. Let's go ahead and take a look at our most recent review for the test coming up here. One thing I will say is remember quadratics are a little more complicated than many of the algebra concepts that you guys have done in the past. And one of the ramifications of that complexity is just a little bit harder, is that sometimes we need different strategies for different problems. And that comes into like making it difficult for students at times because they just don't know what the right strategy is. So on some of these problems, I'm going to attack the problem more than one time, which means I may take longer to do the problem than is necessary because what I would like to see is that on a test, if you get stuck using one method, you could at least pivot and maybe instead of just throwing up your hands and giving up, you may have a different method that would allow you to solve that problem. So with that in mind, let's go ahead and get going on this. So you're going to notice in this very first problem, what we specifically asked you to do is graph the following using factored form. Now, we've recently learned using the axis of symmetry or the line of symmetry as a method to do this, but this one specifically asked for factored form. But I'm going to double check my answer using that line of symmetry that we learned recently. So, first problem says let's factor it. So remember we do a diamond and you want to remember that the product of A and C goes on the top and B goes on the bottom. So since A is 1, B is 4, and C is -5, then I'm going to put that A times C on top, which is -5, and I'm going to put B on the bottom, which is 4. And I'm going to think of two numbers that multiply to -5. Well, 5 is a prime number, so it can only be found using a 1 and a 5. But the product has to be negative, so one of these two numbers has to be negative. And in fact, but they have to add to a +4, so that means the larger number is positive to make the sum positive, which means I don't need a box because A is 1. We've talked about that extensively. If A is 1, we don't need a box. So we can just pull those numbers here and here, which makes my roots x equals 1. And my, I guess I'll put it this way. My roots are at x equals 1 and x equals, I got to be a little bit careful. That was a +5, huh? X equals -5. Now, what we did, I'm going to go ahead and put this down here. My one root is at 1. One root was at -5. And then if I think about that, then the number that is right in the middle of +1 and -5, these are 6 units apart. So if I came back 1, 2, 3, 1, 2, 3, um, yeah. Did I put that? Oh, I put that in the wrong spot. That's why my count wasn't working. There we go. Let's fix that. Okay, so if I went back 1, 2, 3, this should be my line of symmetry. So the graph could kind of help me understand where that is. I got that number at -2. Or what we could have done is we could take the two roots, which we in the worksheet called P and Q, take 1 and -5. We add them together, which is -4, and we divide by 2, and we get -2. And that's an x equals. Well, what that means is my line of symmetry should be at -2, and I should go up from there and down from there. So here would be -1, 0, and 1. I'm going to go down, -3, -4, -5. And remember, we just found out that these two numbers were my zeros. Okay, so we got that. We have all that information. Now we're going to go ahead and plug in -2 for x. So remember, we go into here, we take our original equation in factored form, and we're going to replace the values that we had for x with the x value right here, because this says x is -2. And so I've got -2 minus 1, which is -3, and -2 plus 5, which of course is +3. And so I got a product of -9. And remember, that's really, really nice because those numbers are the same value but opposite signs. So that would be -2 gives me -9. So here is 5, 6, 7, 8, 9. And then I should be able to go over 1, up 1. And then I should be able to go over 1, up 1, 2, 3. Over 1, up 3. And then over 1, up 5. And I have a really nice looking graph. There we go. This looks like a really nice, easy graph. And that matches what I think the graph should look like. Now, I did mention that I'm going to go ahead and take a little bit more time than normal on these because I also would like to remind you that if we went with a newer version that we did second in our lesson, and we use this equation opposite b, but we said b was 4, so opposite b was -4. And I double A was 1, so that's 2. What you're going to notice is we got a line of symmetry at x equals -2, which actually validates what we got over here when we looked at the middle of the two roots. Now, ultimately, two different ways to do the same problem. We could have started with this -2 and plugged it in, which looks like exactly what we did here, and then use the 135. Two different ways to do the same problem. Now, number two, actually, the fact is that factored form is going to be so much nicer than you probably realize. So what I'm going to do is I'm going to try to look at the problem and try to study the symmetry that happens, because you notice here there's a symmetry. It went from -9 to both -8s and -3s and zeros. Well, if you look over here, you should see some symmetry. I got a couple of 24s, right? I got a couple of 9s. I keep going. I got a couple of zeros and I got the 3. So that means this value right here at 3 comma -3 should be the one right smack dab in the middle of my table. So 3 comma -1, 2, 3 should be my vertex. I also can see that it didn't go up 1, it went over 1 up 3, and then it went up 9, and then it went up 15. Huh. Up 3, up 9, and up 15. So when we talk about our 1, 3, 5, 7 pattern, what happened this time is it didn't go up 1, it went up 3 and then 9. It went up 3 and then 9 and then 15. Oh, so in other words, it's this pattern right here multiplied by 3. So that's going to be kind of an important little fact. And we could actually put that on the graph right now. We got 4 right here, 2 right here. 5 gave me 9, and 1 gave me 9. So as far as doing the graph, we've got everything that we could want. Okay, here we go. That looks pretty good. But now we're going to go one other way because I don't know what equation did this. They just gave me data. But the nice thing is right here, if you pay attention to what we did over here, this right here went with this guy right here. That factor went with this root. We could also see that this factor, x plus 5, went with that root. Well, what that's going to give me is if I kind of watch that same set of logic, I see a root right here, and I also see a root right here. And so if 2 gives me the number 0, then I know that x minus 2 had to have been the factor that created that 0. And if 4 gives me 0, then x minus 4 would similarly give me that other 0. And so this should be the equation of this, except for the fact that we don't grow by 1, 3, 5, but by 9, 3, 9, and 15. And so if we were to factor it, it would look like this. And this is a good looking problem. Now, I mentioned I'm going to take a little bit longer because what I'd really like to do is make sure that what we just did absolutely worked. So what I'm going to do is open up Desmos for a second and just check this one problem. So in Desmos, I'm going to hit the plus sign and I'm going to make a table. And my table had numbers like 0 and 24. It had numbers like 1 and 9. It had numbers like 2 gives me 0, and numbers like 3 gives me -3, and 4 gives me 0. And you'll see the calculator or the computer is populating those different cells. And so when I did my work, I said, y is parentheses. We said it was x minus 2 because we wanted to line it up with this particular root. And then we did x minus 4 because we wanted to do that. Now notice that I hit my roots like I wanted to. These two values are good, but it doesn't hit the other ones because I needed to put the 3 in front to modify the growth factor. And as soon as I put a 3 there, you can see that my data table matches my graph and it matches my equation and it looks fantastic. So hopefully that was helpful. And I think I'm going to go ahead and stop that video right there. And hopefully that was helpful to you guys. And I will see you guys back in class. Thanks for joining me.